As China's first domestically developed jet airliner, the C919 has captured global attention since its launch in 2022. Thanks to its strong cost-effectiveness and reliable performance, this aircraft has secured over 1,400 orders worldwide within just a few years. For a brand new domestic model that initially faced skepticism from the outside world, this is, honestly, a remarkable achievement. But the importance of the C919 goes far beyond commercial success. Its arrival signals that China is gradually breaking into the world's top aerospace technologies. For decades, the global mainline airliner market has been almost entirely dominated by Boeing and Airbus, leaving Chinese airlines with no choice but to rely on these two giants. The C919's emergence directly challenges the US and Europe's long-standing dominance in the aviation industry. Unsurprisingly, this rapid rise has hit a nerve in the West, particularly the United States. Whenever China shows the potential to challenge global leadership in any field, the US often responds with measures to contain it. Now the C919 has become a point of tension. According to a recent New York Times report, the U.S. Department of Commerce has suspended certain licenses that allow domestic companies to export technology and components to China's commercial aircraft projects. This move clearly targets the C919. Some U.S. officials have even claimed that without American technical support, China might struggle to deliver even 200 aircraft over the next decade. This raises two key questions. Can the U.S. really achieve its goal of slowing China's aviation progress? And how will China respond to this external pressure? If you enjoy our videos, click subscribe so you never miss our latest content. Now let's dive into today's topic. By 2023, China's C919 officially began commercial operations. Nearly 2 years on, the aircraft has accumulated over 23,000 hours of safe flight time, completed more than 9,600 commercial flights, and carried over 1.27 million passengers. For a new model, this is an impressive record. Because of its performance, airlines in Brunei, Indonesia, Brazil, and other countries are considering purchasing the aircraft. In April, Malaysia Airlines also expressed interest, evaluating several Chinese-developed aircraft, including the C919, C919, currently under development, and others. On May 8th, Ryanair, Europe's largest low-cost airline, announced it was considering the C919 and stated it would place an order if the price was 10 to 20% cheaper than Airbus models. This marked the first time the aircraft entered the radar of mainstream European and American airlines, drawing significant industry attention. However, promoting the C919 globally is not without major challenges. Airworthiness certification is often referred to as the golden ticket in aviation. Securing certification means a domestic aircraft can officially enter a foreign market and unlock upstream and downstream industrial chain orders worth over 150 billion yuan. To obtain international certification, Europe and the United States conduct thorough reviews of an aircraft's design, manufacturing, testing, and service processes. This strict scrutiny makes it difficult for foreign aircraft to succeed. Moreover, for decades, Boeing and Airbus have controlled nearly 98% of the global large passenger aircraft market, a near monopoly. Granting certification to the C919 would upset this balance. Recently, United States pressure has intensified. Starting in March, the Trump administration imposed tariffs on over 180 countries, with rates on Chinese goods soaring to 254%, heavily impacting China's foreign trade. China retaliated with a 125% tariff on American products, raising the prices of United States aircraft and parts and potentially discouraging Chinese airlines from accepting Boeing orders. The Chinese market lost up to $28.2 billion in potential Boeing sales. Even after a temporary compromise on tariffs, Trump's administration targeted the C919, suspending export licenses for key technologies, particularly the LEAP-1C engine. While the C919 is domestically developed, it still relies on external suppliers for critical technologies, especially engines. The LEAP-1C, developed jointly by the United States and France, delivers up to 13.5 tons of thrust with roughly 60% mechanical efficiency, 15% improved fuel efficiency, 10 decibels lower noise, and significantly reduced emissions. Unlike the bare-metal LEAP-1A engines used by Boeing and Airbus, the LEAP-1C is a fully integrated system including the engine body, casing, tail cone, thrust reversers, and exhaust devices. Because over 30% of the LEAP-1C's components come from the United States, any American supply restriction affects the entire supply chain. Even if France intends to supply engines, U.S. export controls make it difficult to bypass restrictions. This also threatens potential buyers such as Vietnam and Kazakhstan, who may hesitate without a guaranteed engine supply. However, in the long term, U.S. sanctions may not succeed. When the C919 project began in 2011, the China Aviation Industry Corporation anticipated potential neck-stalling risks. They simultaneously began developing the CJ1000A engine, investing over $2 billion in research and development to match global advanced power systems. The goal: more than 13 tons of thrust with better fuel efficiency and lower emissions than the LEAP-1C, 5% lower fuel consumption and 40% fewer emissions. By 2023, the CJ1000A completed its first high-altitude test flight on the Y-20 transport aircraft. Tests showed 12% faster startup in extreme conditions, 3% better fuel efficiency, and 25% lower maintenance costs compared to the LEAP-1C. By May 2025, the C919 prototype B002K replaced the LEAP-1C with the CJ1000A, completing 500 hours of verification flights with stable performance. Localization of the CJ1000A has reached 80%. Chinese enterprises now manufacture core components, from high-temperature alloy blades to advanced ceramic composite nozzles. Innovative alloys allow turbine blades to operate reliably under extreme heat exceeding 1,600 degrees Celsius. Thousands of sensors monitor the engine in real time, ensuring optimal performance under complex conditions. GAP-1. China's independent airworthiness certification system is gradually breaking Europe and the United States' long-standing monopoly on aviation rules, making it easier for domestic aircraft to go global. COMAC plans to mass-produce the CJ1000A in 2026, starting with 50 engines annually, and scaling up to 200 by 2030, supporting large-scale C919 deliveries. The LEAP series has dominated the narrow-body market for 2 decades, but the rise of the CJ1000A is quietly changing that. Beyond the CJ1000A, China has invested billions in the CJ2000, a high-bypass turbofan with up to 35 tons of thrust, comparable to the Trent 1000, Trent XWB, and Genx engines on the Boeing 787 and Airbus A350. Fuel efficiency is 15% higher than the CJ1000A, meaning each trans-Pacific flight with the upcoming C919 can save about 20 tons of fuel, reducing one-way costs by 15%. The CJ2000 also features a 12-to-1 high bypass ratio, advanced geared transmission, and innovations such as directional solidification single-crystal turbine blades. This reduces scrap to 7.8%, increases temperature resistance by 200 degrees Celsius, and enables stable operation in extreme conditions up to 1,700 degrees Celsius. In March, the CJ2000's core engine C2XC101 was successfully ignited, reaching 100.6% engine speed in subsequent tests. With China's growing engine research and development capabilities, even United States attempts to block the C919 through the LEAP-1C will have limited effect. To stay updated on our projects and news, subscribe to our channel and turn on notifications. We'll continue bringing you more exciting and insightful content.